About 3, 2, 1. All right, so we should be live now. There's my hand right in front of me. And it's dead center, but it's still just a little off to the right. That's okay. Anyway, thank you so much for joining. Just a couple thoughts I had in mind. I'm gonna maybe not look out this window here. So thought number one was I've heard a lot of requests for a keyboard recently, and last keyboard we made was a long time ago. Keyboards are pretty easy to make. It's the complex part is if you want to do it on a low capacity and make it really, really good. So anyway, I thought that might be something worth looking at if you guys are interested in that. And then the other thing is I recently published just yesterday a new world. I'm not sure why it's asking me to do that. Yeah, Supergiant Popping, this one here. So this world's pretty cool. It could use a game manager though. It's currently all running on itself. And but so yeah, I thought that might be kind of a fun thing to look at. I built the script in less than 30 minutes, so if you guys wanted to take a quick look at that script, it's a singular script that runs an entire game, which is pretty cool, but it's also like, it's just the starting point. Anyway, so also welcome. I can see the chat messages, so feel free to leave some comments. I do need to check my focus. I just remembered that, and I can see that the color is yellow, but on my camera screen it's not yellow. Some guy was commenting just the other day. He was like, man, the coloring on your setup is wonky. Oh wait, no, I just forgot to turn on the right lights. Never mind. There we go. So now we should be in much better sets. Let's see how that looks. So we should be color-wise really solid, and see some of my panels got moved around. Okay, that's totally fine. I'm gonna quickly adjust one of those. So my chat windows are via a really cool trick. Let's see how there we go. And on the main channel, there's a video called Netflix and Chill if you want to learn how to get access to panels while you're in Horizon. And so now my chat's right here with the camera, which is what I was hoping to do. And then what I can see, which is also cool, is I also have a window into the live stream. So now the color looks good. Yay, we fixed the coloring, and that looks much better. Okay, perfect. So with that, let's go ahead and I'm going to move those over just like functionally it is much better to have those just for viewing purposes right there and there. I wish you guys could see this. There's a way to capture it. Jackal Dude told me, but I'm not smart enough to remember everything that Genius has shared. But huge shout out to him making that tutorial on the main channel. Okay, so again, we were looking at potentially doing a keyboard because it's relatively easy and a lot of people have been asking recently. And we just don't have a really good asset version of that. And then the other thing was doing a game manager. So let's go ahead and start by heading to an empty world. And then if you guys have any suggestions, comments, please feel free to dive right in. I'm going to create a new world. And we're going to call this Keyboard 2.0. Keyboard 2.0. There we go. And create. It's kind of weird. I've gotten to this point where I'm remaking a lot of stuff recently, which is kind of the reason, and there's a lot of, I never have just one reason, but it's kind of a part of the reason we haven't seen a lot of new content on the main channel is because I've kind of done almost everything over there. Like, there's so, like, we have at least 2 tutorials on snow. So, it's just kind of crazy. Like, at a certain point, you know, we've made over 700 videos in the last 2 years. And so, it's exciting because I'm going to tackle this in a new way that I've kind of learned over the last year since we made this first one. And just to quickly show you what the brilliance of Wafflecopters is, he took a raycast, invisible cube. We don't actually need it to be invisible though, so we'll leave it visible, and a text object. And through some fancy math, he was able to make a keyboard using just these 3 objects, and that was it. And it's the most efficient keyboard you can make, and you can have tons of them. And so while that is the dream, I'm not sure if we want to even attempt it. I mean, at the very least, we'll give it a go, right? So the first thing we need to know is that this is going to come out of our finger. You won't be able to see it coming out of our finger, but we need to visually understand that there's a thing coming out of our finger, and therefore the raycast distance should be no larger than 0.5 meters. Maybe we'll go with 1 meter, but that is going to come out of a human's finger. So we should also scale it down to be kind of finger sized. There we go. And so that is our raycast. I'm going to leave it pointing out, right? Then we're also going to need a script to write our script. And what I'd like to start by doing is just building a basic, what I should also quickly share is that if you wanted to build a really super duper simple keyboard, you just use a trigger and do when trigger is entered, send event, based on this is the key. There's definitely a really easy way to do this, but it takes up a ton of capacity. And so we're just going to play around and kind of experiment with the with this idea of a low capacity keyboard and see if we can't come up with something that's relatively easy to implement for everyone to kind of if you wanted to redo this yourself. So I'm making this kind of a blue metal keyboard, which I like. I also want to have some accents on it. And so I'm definitely taking this beyond its original level, but I think that's a-okay. Go ahead and snap this right into the middle of this guy. Oh, that is still so much bigger than I would have thought. It's manually snapping off, slide that just to be some accent on the side. This aesthetic is, for me, I was inspired by Matlow 3D, and I've really enjoyed how he uses, sorry, a little something in my throat, how he uses glowing white unlit lines to make his stuff look really futuristic. And so you've seen it in a lot of my more recent work, and that's who I was first inspired by, although I'm sure there's a lot of other people, and maybe he got inspiration from someone else, but I just kind of really like the way that looks. Okay, so this is the board on which our keys are going to be done. And so what I really wanted to do first and foremost was see if we could just highlight the keys. I think highlighting the keys is kind of the first step for making a really good keyboard. And so what I wanted to do was just also get our sizing right. So we'll go A, B, C, D. There we go. And we'll turn off auto fit, so it's a fixed font. And we can leave it at 10. That's fine. That might give us some more benefits later. And then we're just going to scale this to here. And then I'm going to remove the Z-ripping. And so now we've got our raycast and our script. And then raycast. So imagine the script runs on the tablet itself. I don't want to do this locally scripted, even though it would improve the speed. But for now, I just want to do it using probably on update. And then we'll do an if not. And so operators tab not equal symbol. And so on update is an event that runs every frame. It's here on your events tab. And when world is started, we're not going to use at this point. And so on update, we're going to do an if the owner of, so actions tab, scroll down to owner of object, put that into the A slot. And what we're checking is to see if this keyboard has been picked up by someone, because the owner of will change the moment someone picks up the keyboard. So we say owner of self is not equal to server player, because the moment this is grabbed, somebody else owns it. The other thought, though, is do I really want the ownership transfer to happen when someone grabs this, or do we keep it static? Probably best for this to be grabbable. So I guess we'll go ahead and zoom in and make this interactive grabbable. And we're also going to attach this script that we need to rename to it. So that be that drop down. And we do have this text object that's currently on the outside. I'm going to leave it there for now. We'll move it in a minute. And so now we've got an on update. I'm going to go ahead and call this keyboard 2.0. 2.0. Okay. And the thing that we want to do on update is kind of the main thing is we want to draw the I say draw, but that's not the best way to describe this. So we're going to create a string variable called display me. And so we want to update the text every frame with what the current frame is. So display me, there we go, click confirm. And then we need a text object, so we'll drop down, select objects. We're on our variables tab, creating some variables. And this will be called text object, enter and confirm. And so the final step of this is always display text on text objects. We'll find display text here on the actions tab, drop that into the if, and then grab display me, put that into here, and then drag text object replacing self. Okay, so with that set up, the other thing that I wanted to do is say when object is released by player, so go down to grab events. When object is released by player, let's actually transfer the ownership back to the server player. Although maybe if they're holding, no, because you might want to be like standing back once you let go. So never mind. Okay, so that's fine. And then the other thing we need to do is have a raycast. Now this raycast is going to allow us to fire and find out where the finger is pointing. And so we'll call this raycast and confirm. Okay, so first thing we want to do is operators tab, raycast with overrides. Let's go find that. I think that might actually be on the actions tab now that I think about it. There it is, raycast with overrides. Now overrides allows us to specify some more information, which is great. So we'll go ahead and drop raycast into the raycast slot there. Then we need an origin and a direction. And these are both relatively simple because we know the owner of self is not equal to server player. So we're going to create a new variable called current owner, which will be a player variable. And so we'll call it CUR owner. And the reason we're doing this is to make our script a little bit more efficient. So we grab set2, and we're going to set the current owner to be owner of self, and then do our check here. But it also means that we can use this variable over and over again rather than having to constantly call owner of self. And so then the origin position is the fingertip of the player. So we'll go to operators tab and go to, operators tab player. There it is. Position of player goes into the origin. And this is the position for our case as the right hand, just for now. We might want to make this left-handed as well, but for now we'll do right hand. So raycast from right hand position of current owner. And the direction is the forward direction of player's right hand. So we'll use current owner again, and then drop down, select right hand. And now we're constantly raycasting from the right hand. Now we do need to do some testing early on to make sure that this is working correctly. And so to test this, what I recommend we do is currently put some sort of effect or something to show where the raycast is hitting. And I think we'll just move the text object for now as just kind of a brief demo. So we'll grab move to and move the text object. So we'll go over to variables tab, text object to the hit point, which we go to operators tab, scroll down to get raycast data, and then grab the hit position or hit point. And from this raycast, there we go. So we're moving text object to that get hit point. Now the thing is, this might not always hit, and if it doesn't hit, we don't want to move. So we need to scroll up to grab another if, put this indented into the if, and then go back to our operators tab where we can get raycast data again. Or if you want to save some time, go ahead and grab this one, thumb sticking to the right to duplicate it into the if. And now we're not getting the hit point because that returns a vector. We need to get did hit, which returns a Boolean. A Boolean just means true or false. And so it's saying, did it hit? And the answer is true. Then we move the text object. If it is false, meaning it did not hit, it will then not move that hit point. So there we have it. Let's go ahead and give this a try, because I think this will work. So we're going to go and drag our raycast into this field here. So we're going to drag raycast into raycast. Important that we switch this to both players and objects, although I'm not actually sure if that even matters. But anyway, we'll leave it. I'm really not sure if that matters. And then text object, we drag this text pill into the text object pill, and now everything has been referenced. Okay. Weirdly, this seems to have cleared out. Oh, because we're constantly running the display me, and because I've selected this in build mode. Oh, look at, wow, it's working. Well, if you wanted to know if it was working, geez, and that's pretty fluid actually. Wow. Okay, so now it's not hitting. So if you didn't catch what happened there, when you select an object in build mode, you become the owner of it. So in our keyboard, we need to do a quick event which says when world is started, transfer the ownership to the server. So we'll go do Actions tab, transfer ownership of object. There it is. And so we're going to transfer the ownership of self to server player. So I'm just thumbsticking to the right to duplicate that. And when you duplicate, you don't have to return the pill back to where it came from. It just takes it as a copy. There we go. So that looks good. Now with that set up, we should be able to play this again. And now it should not be tied to my hand because of that. So now see, it's not doing anything. Now when I grab this, you can see the text object is moving around to the hit point. Although I am noticing it is hitting on my hand, and that is a bit problematic. So we want to make sure it can't like hit on players. Although maybe that doesn't necessarily matter. But yeah, that's really cool. So that's a really cool working demo. I am shocked at how well that worked. Okay, so we're going to go ahead and stop that. So keyboard, it's got this really simple script. I can see we've just had someone join us, so welcome. I can actually see your chat messages. If you'd like to comment, feel free to do that. Just to quickly walk you through where we're at right now, we're creating a new keyboard, and this new keyboard is running on this tablet here. We're trying to make it as efficient as possible, and so we've got the text object with a raycast and one grabbable, which makes it super duper efficient in comparison to previous keyboards. And so what we've done is said when world has started, we're transferring the ownership of self to the server player. And then on update, which happens every frame, we are then setting the current owner to the owner of self, basically figuring out who is holding on to the object or who has grabbed it most recently. And if the current owner doesn't equal server player, we can then raycast from the right hand of the current player. So that's the position that it's firing from. And then using the forward direction of the right hand. And then if gets did hit from raycast, move text object to the hit point. And so what I wanted to try, and then we display me on text object, which we haven't set. So I just kind of wanted to fill this in with some default text. Let's keep this as ABCD for now until we actually set that up to start doing highlighting, which will be the next step. But what I wanted to do real quick was go into our raycast and see if changing this from both to just objects will prevent it from hitting players. So if we go down and hit play, come into the world, grab this. Now, if I point, it is hitting that, but it's no longer hitting on me. Okay, that's perfect. So yeah, switching that to objects tagged, even though it does hit objects, like this object is not tagged, which is why it's like, really? But anyway, so it's working, so that's perfect. Now I wonder if we really wanted this to only engage with objects tagged. So let's go ahead and tag this key. So maybe key KB for keyboard. And then if I go and hit play, will this not work because no, it's still working because it doesn't care about objects tagged. Interesting. So that doesn't seem to have an effect. Might be because we're using raycast with overrides, but I want to use raycast with overrides, so that's important for us. But I am curious if there is a did hit object, and I wonder if that will refer, like did hit, maybe it just is like everything that's not players. So maybe did hit object will require it to be the object with the thing. So anyway, sometimes when you don't know, which is sometimes often the case, we can grab, and now we can see that that is actually what was happening. So now that we've used did hit object, we are only working if we hit the object that's been tagged, which has the nice effect that if we open up the properties panel here, attributes tabbed, and go tag, we can type in capital K, capital B, enter, and voila. Go ahead and hit script play. Whoop, play. There we go. And now it works again. Fantastic. Okay. So now the moving of the text object was just to prove that our raycast was working. And what we want to do next is potentially draw a point out of the player's hand. I feel like that could be nice. I'm not sure though, because you also need to get a clicking, right? So there is this potential where we don't use raycast with overrides, and instead we do one of these things. So there's a new shape that's super efficient. So shapes tab, and you want to look up Platonic 01. It's the most efficient shape in Horizon now. So there it is. And kind of looks like a pointer, which is nice. And so I'm thinking we make this object grabbable, super pointy, make it about the same length as this guy, and then So does that even matter though? Because we could just put this on the tip of this guy. So it doesn't really necessarily have to be. Okay, let's see. It's like, are these oriented together? I can't tell. Kind of looks like they're got the same orientation. Go ahead and snap that. There we go. That looks good. And I think this needs to go out just a hair further. So that should work. The problem being that you might expect for this to be something more like that. And so far it's not actually colliding. So maybe we can go back to here. So the thought is we make this a grabbable object, and then we no longer have to raycast with overrides because it's coming out of this grabbable object. And then we grab something like a, I mean, we could use another Platonic 01, but I'd prefer to use a cube, kind of match the aesthetic of this guy. And then pop this into here, grab the unlit aesthetic of this, pop that into there, and then make this non-collidable. There we go. And I'm also thinking we might want to shrink this down a little bit. So let's go shrink that, snap it into the center here, and then select, scale that down to here. There we go. So now we have a very clear indicator line. And then this would be the grabbable piece, which we can select and place there, which needs to be hand sized. So maybe shrink that down a bit, stretch it out a little bit. There we go. Okay, we can make that look cool later. Ooh, there we go. Okay, so now the thought is we group these three together, group, and make this interactive and grabbable. Now this does add a little bit more complexity to our keyboard because we now have this interactive object, but theoretically, we go in here, and instead of using raycast with overrides, we go to Actions tab, and there's just simply raycast, and then drop that into here. We no longer need to do this math to get this position, which is good and bad. I think I might actually undo this when we're done. So let's take a quick peek. I'm sure it's going to work, but I kind of want this to be super duper efficient. And as cool as this is, like having this, so the idea is that when we grab this, we can now point and it follows it around wherever we're pointing. Like that's really cool. Oh, but you need to get the index trigger click. That's the reason we needed a grabbable, is so you could know when they press their index trigger. So you know when they're like clicking. So I guess we do need this, and it does make the script easier for other people to read and write. So, but that would allow us to do the index clicking. So when you want to select something, and it's a pretty good visual indicator. It doesn't look super crazy. It goes through the back, which is kind of funny, but it also shows you how far away you can stand. So there's that. The lag isn't bad at all, considering this is like default scripted. This isn't locally scripted, so pretty impressive. Okay, go ahead and let go of those and stop. So what we could do, though, now that I think about it, is instead of, yeah, that might actually make the script a little more efficient. So we were using the keyboard script coming off of this guy. Let's go ahead and remove the script from this tablet. Let's make the tablet non-interactive. So this is going to save us capacity. And then, so now it's a static keyboard that can't be moved, which is probably the use case for most people anyway. And then we put the keyboard script on the pointer, which makes sense because then if you grab it with your left or right hand, so that's another benefit. Now we're going to drop down, select keyboard 2.0. And we do need to reference everything all over again. So let's go do that real quick. So drag text into the text spot, zoom into this grouping so we can go grab the raycast and zoom out. And then drag raycast into the raycast pill slot. Okay. So now this should work nearly identical, but let's quickly check. Make sure the script does world is started, transfer ownership of self to server player on update. Set current owner of self. If current owner doesn't equal server player, raycast with raycast. Okay, that still works. If get did hit object, that should still work. Move text object to hit point, that should work. Display me on text object. Okay, there we go. Let's go ahead and hit play. Give this a try. So we grab that, pointing it down. We're getting some crazy Z ripping, so that's That's just an unfortunate side effect that will be fixed with the final release, but that looks great. It works great. It's functional just like we'd expect, and it's now got the same efficiency as the original model, so that's great too. Next up, let's go and stop moving the text object around. So this was previously just so we could determine the hit point. So for now, let's go and just for fun, no, we don't need, maybe, I don't know. Well, I need to save this value. So I'm going to use debug print just so I can hold on to this get hit point because we are going to need that. I'm going to delete the moving of the text object because that was we never needed to move anything around. Display me is what we want to update. And so we need to build a text object that has an array of positions and letters. And this isn't as crazy as it sounds. So we go into, let's go to string list and give it a name, and we'll call this keys. So whatever the keys are, we'll click confirm. And then we'll go to a vector list and call this, this vector list will be called key positions, and then we'll click confirm. And so for every key, there must be a key position. And then what we can do is come into here and then type in the keys one at a time. So the first key is this, and we'll go enter. The next key is a 1. And so we just want to design this to model exactly with the keyboard that we have here in VR. 1, 2, this will take a second, so just kind of bear with me or fast forward if you're in the future. And 4, and add number 5, number 6. We really just needed this to be a demo. I don't know why I'm going to go for the entire keyboard, but you know. You only have to do it once, I think, is the main thought here. Is like, okay, once we're done, then we never have to do it again. 9, 0, and then we have a minus symbol. The ones that I'm kind of curious on how I'm going to solve are the backspace, enter, and maybe these kind of like downward ones. So I'm kind of thinking about skipping these side panels here and instead coming back to them. So if we just did 1 through equals, we do have an uppercase button, and I guess that's on both sides. We have a tab of caps. Yeah, we're gonna have to come back. We're gonna have to figure that one out in a second. For now, we'll go ahead and click enter, and then we're on to the next line. But there's a backspace, so I'm just kind of like, do I put in the back arrow equals symbol for backspace here? Let's go ahead and try it just with one line. I think that's a good starting point. Now for key positions on world start, we need to have a special like initialization. So I'm going to create an event called initializer, and I'm just going to call it init for initialize. And then we will send event with delay. And I like to just delay my starting events just by a little bit. Find it is sometimes better. So that's good. So we'll send it with a 1 second delay for now. And then when initializer is received, the goal is to create a key position list. And then we also need a secondary list of key positions. And so this one is going to be called string list. And then we'll call this keys display, and click confirm. And so then what we want to do is use a while loop, drop that here, and then say while this does not equal this. And then what we're going to use is length of list. And so while the length of the key position list does not equal the keys list, I want to add positions for each of these. And I was thinking of just adding these to the keys display, because then we can, yeah, we'll use that later. We're not going to use that now, but we'll use that later. And so you could even, if you really wanted to, just on initializing, set the keys display to be keys. It's not required, but it could be done here. I think we're going to have to do it again later, but There we go. That's what that does. Basically, it sets the list to be identical to the other list. And then what we want to do during the while loop is build up the key position by recognizing the first one is the first position. Now we do need to calculate positions. So our keyboard is not to scale yet, so we should try and get a good scale on this. Let's consider this to be a 1 meter keyboard. And so I'm going to scale this to be 1 meter wide. And I'm not sure what the easiest way to do that is. So set this right there. I think this is already on the 1 meter mark. So it's actually a ½ meter at this point. So now it's a meter. Perfect. So we'll scale that up. Put that into useful spot right about there is perfect. That looks like a pretty decent keyboard size. We'll go ahead and put text there, sliding it down. Perfect. And so when we know this is 1 meter in length, we can then divide. The thing that we need to do first is ungroup this asset, then select it again and group it. Now the benefit to doing this is that we know that this is 1 meter in width, and the scale has been set to 111 because we've just grouped it. And so in the future, we can use that math to know that if somebody scales this, that it's the right scale. And so what we're trying to determine is we've got how many items in this list? 14 items. So we're going to take this and divide it by 14. And so we need to know the, what is it? It's using the X. So the X width. And that is how far apart these keys will be divided by 14. And so we'll go ahead and create a, we'll create a new variable. And this is only being defined so that you understand what it is when you read the script. It's really not necessarily useful as a variable itself. So we're just going to call this keyboard width characters. Maybe character count. Oh no, did it really? So maybe we'll do KB character count. KB character count width. Okay, that's not the best description, but it's better than nothing. And so we know that there's 14 characters on a line. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Perfect. Okay, so we got KB character count width of 14. Then we go to keys displayed. No. So right here, to determine the length of the first position, it's got to be up an amount and then over an amount. We also need to use some fanciness to make sure that our widths are correct. And I feel like there's a way we could script the calculation, but we might need to just create a new string variable, just for now at least, which is going to say monospace. So we call this MONO, monospace equals, and I'm going to guess that this is related to the width. And so sorry about that. The Airlink connection seems to have been lost. And there it is. So I'm going to reconnect. Apologies for that. Coming right back. Either I need to buy a new router, or Airlink is not as stable as it looks. Library, MetaQuest. Okay, there we go. Loading back in, so that should be coming through over here. There we go, maybe. Looks like it might be loading. There it is, perfect. Okay, so you guys are back in. And then I'm going to go ahead and bring our chat windows back, which unfortunately does take a second, so just bear with me there. Chat window. There you guys are, right there. Pin. Then while we are traveling, I'll do the other ones. So, Greet tab. Edit keyboard 2.0. Perfect. Okay. And then the last two windows from over here. Add desktop panel. Add OBS. Boom. OBS, hint experience, and last desktop panel, Google Chrome, live streaming. There we go. Okay, guys, we are back. It's kind of weird. Like, this used to be a little bit more stable. Not sure. Sometimes it's just a learning experience. I'll have to figure out a better methodology. Okay, and pen. We are back at our keyboard. Okay, so previously we were creating a monospace, and I was working on making a string variable for it, but I'm kind of just thinking, let's do it over here. So the thing we need to do is we do that down here under display me. So right here, when we're working on our display, we set display me to be this monospace thing that we're working on, and it's similar to what we're currently working. It's just I don't know if it works. So I really wanted to try it and see, but I guess I can't until I guess I could right now. So we're gonna set display me, but first we're gonna try it down here. So monospace is a cool code, and if you want to know about all the codes, go to your asset library and search for text, and then type format, and you should see the reference. There it is. Pull that out. And so here are all the codes, and these are very useful to us. The ones that we're most interested in are going to be potentially line height, as well as monospace or mspace. Good thing we looked. Mspace equals 0.1, and I believe this is in meters. So I'm thinking we can calculate that by figuring out what is a 14th of a meter. And so if we go to here, we're going to try and think about that and say, okay, so it would be 0.1, so it'd be like 0.7, I think. So we're going to go mspace equals 0.07, and then that's our spacing. And there's 4 characters, so A, B, C, D. We actually want to try and type out the first line. So it'd be, the first line is this. This is actually way easier to type over here when I don't have to do that. So there is our, oh gosh, that did not work. Okay, so it's not in meters. That's the first thing we've learned. So 0.7 was closer. 0.5 is where we want to be. So each of these characters are spaced, but the size is too big. If we go to 5, now the spacing is still the same, but we've got this really nice, yeah, those look really good. Okay. So with that, we also need to know that there's multiple lines, but we'll come back to that. Let's just start, like I said, I want to start with the basics. So we did figure out that monospace needs to equal 0.5. So we're going to go ahead and type this in. String input. We want to use some plus symbols. And the reason we're going to use some plus symbols is so that we can make sure this is accurate no matter if someone scales this or not. Thing is, we don't have this object in here, so we need to have a reference for the keyboard object, which reminds me that when we ungrouped this, we forgot to go to the attributes tab and re-tag it as KB. So we'll go ahead and type KB, enter, okay, and there we go. So now with that, we're also going to go into our name here, and we're going to call this keyboard surface. So this is the surface of the keyboard, and click confirm. And so our KB surface, we can then get the width of it. So we know that the beginning of this string is mspace equals, yeah, so we'll go ahead and grab that, mspace equals, and then we're going to add a decimal because it should always be a decimal. No, that's not true. It's not always necessarily a decimal. But we do know that it always ends with a close bracket. So we'll go ahead and grab the closing bracket there, and then the number needs to be like relatively easy to read decimal. So I'm going to grab a couple things to do some math here. So if we're going to divide by 100 so that it's always 2 decimal places. So we divide by 100, so it's always in 2 decimal places. And then to make sure that it's a whole value above, we're going to use the floor function, which should be good. And then we're going to need to use some more math to get this value. So we know it starts as 0.5, but if somebody scales this, we need to modify it. So it's like 0.5 times the width of this, so the x-axis scale. And then we need to multiply that by 100. So it's actually more like not 0.5, but 50. So you take 50 times the width, which we can go to operators tab, and we need to grab the x of from vector math, and then go to object and grab scale of object. And this is the scale of our KB surface. So this is currently 1. So 1 times 50 is 50. Flooring 50 is still 50. 50 divided by 100 is 0.5, which then 0.5 needs to be converted into a string. So let's actually duplicate this and then delete this. Oh, not that whole thing. This whole thing. And then grab variable as string so that we convert the number into a string value so that it plays nicely with our code. There we go. So now we've calculated our M space so that it's always the correct spacing, even if you scale the keyboard up. So that's the good news. Now the next thing we want to do is determine the position of each of these. So we know that this should be 14 segments, but it's really not because oh, it's not perfectly 14, is it? I think we're gonna leave it for now. There might be, well, there's this opportunity where we take this and we scale it just a hair, like just a hair. Snap that, undo that piece of grossness. There we go. And now that's more perfectly aligned with the edge. We might need to shrink it in a little bit in a minute. Okay, so that should work. Okay, so what we were working on here is we were trying to determine the position of each of these letters. So we've got this while loop in place, and to determine the first position, we know that it's going to be on the far left side, and then it's going to work its way over to the right side. And so we need a starting position. So we're going to go create a new variable, which will be a vector, and this is going to be called start position. And right now we're only doing one line. So we don't need to worry about this upward corner. We only need to worry about this piece here. Eventually, we're going to add this other axes, but for now, we're just worried about this one axis. Okay, so we're going to start by setting starting position in our initializing phase here, right before the while loop. And so the start position is going to be, a forward direction. Which direction? We're on the x-axis, and the x-axis I believe is our forward, or is it the z? Let's see. So your forward direction is along the z plus. Got it. Okay. Well, that makes this even more complicated. So z plus is our forward, and x, and there's y, and so we're going to need to do some cross products, which I know it sounds complicated, but it's not too bad. We'll be able to work through it. So right here, this is our forward direction. This is our upward direction. If you take forward, the forward direction, cross an upward direction, you get the other direction, and it's either pointing this way or this way. We need both of those, so totally okay. We just have to figure out which one is which. So the starting position is also going to be based off of our width. So we need to grab a couple things. Let's start with the plus symbol because we need to add these together. So we're going to take the current position of that object, right? So we say position of, go down to position of object. There we go. Put that on the left side. And the position of the keyboard surface is that first starting point. And then we need to add to it with half of the scale. So we need to take this and multiply by 0.5. So we're going to scale, and because we only need to go halfway across, so I'm going to grab this number and put that on the side, type in 0.5. And then to get the direction, it's that cross product I just told you about. And so we're going to go grab cross product. But I'm thinking it also needs to be multiplied. So I'll explain this as we go through it. It's kind of hard to explain, but let's go grab the multiplication symbol. And then remember down here where we calculated the scale of the x? We need that again. So we're going to bring that up here. And by multiplying it by the scale of the x, that tells us how wide this is. So that scale of the x is the width of this surface. And so we need to multiply it by that before we cut it in half, because the cross product returns a value of 1 meter. And so 1 meter times whatever the actual scale is will return the correct width. So then we're going to go down and grab the cross product, which is right here. And now the good news is this is either A or B, so we can swap them if we're wrong. So that's the good news. But we want to grab, where is it? The direction of an object. So going to object, we need to grab the forward direction of object and the upward direction of object. And then we'll reverse these if I'm wrong. And then the object is the KBB surface. So we'll go plug those in. And we do have one more error in here, which is right here, because raycast get hit point from, oh, I see what I did wrong there. That's weird. I'm not sure how that happened actually. So this was supposed to be a comment, but occasionally you'll grab something from over here. I need to report this bug. And then when you drag it over, it's actually grabbing something from over here when you grab over here. Makes no sense. And I didn't want to comment. I actually wanted a debug print so I could grab the get hit point and put that in here. And then raycast goes into this. So I made a mistake at some point when I was dragging stuff around. Okay, so then we're saving that. That fixes that bug. I also only want to do the display update if there's a hit. So we're going to put this in here as well. Okay, and then scrolling back up, what I wanted to do now that we had this calculated was move something to that position so we can visualize where it's at. So we're going to go grab the move to, and we're going to move the text object to the start position so we can visualize where it's at. But because we haven't referenced a bunch of stuff, we're getting errors. So opening up the properties of this, opening up the properties of that, we can drag this group reference into the KB surface reference. And with that in there, this might work. Go ahead and hit play, see if I made any other mistakes. 1 second. And it went the other direction, so I told you I had to go one way or the other. So we know it needs to go the other way. So go ahead and hit stop and clear. Now I will point out very quickly that you might have seen it was midway in this object. And so we could calculate the upward direction and move it up by the scale, but we're not going to do that. So it should be accurate enough for our purposes, and it shouldn't need us to calculate the upward direction. Okay, so we've got this, but these were in the reverse. So we're going to duplicate this line, and then I just like to drag this to here, and then drag this to there, and then delete the extra. So there we go. Now if we run play, we'll see that move to the left side rather than the right side. Yay, we've calculated the start position. So we'll go ahead and click stop. The while loop broke the script while we were doing that because I didn't actually fix this. Anyway, that's fine. So we've got the text object, like we've proven that the start position is the start position, which was the point. So now we need to go in the opposite direction by 1/14. And so I'll show you how we're going to do that. So the start position is the first position added to the list. So we go to our operator tab, scroll down to list, where we can grab add to list. And so we'll drop that in here. And then we add based off of the length. So we're adding to the position list. Sorry, I'm getting some crazy headset lag real quick. Let's see if I just shake it out if it'll. Okay, it seems better now. So we're adding a position to this key position list, and the position is two things added together. So we'll grab the plus symbol. We start with the start position, and then we add to the start position with the position, the direction. So then we need to multiply two things together, which is the, we need to get a division. And so we know that it's 14 wide. So here we have the width is 14. So we take the character count width and we take 1. So we want this to be 1/14, except for it shouldn't actually be 1. This value is the current length of the key position. So the current length is 0. So it's not going to move the first position. The first position will be the start position. Then the second position will be the 1 and then the 2. And so it moves over by that amount, so that's good. And then we need to multiply this by the direction, and the direction being normalized by 1 would be okay, but if the width is wrong, so we need to multiply by the width if somebody scales this. So we grab the scale of the x, so it's this same equation that we did here. But then the difference is that the cross is the reverse cross. So one cross pointed to the left, this cross needs to point to the right. So we put upward direction on the right and grab forward direction and duplicate it to the left. And so now we're pointing that way, multiplying by x scale of KB surface. Okay, lots of multiplying to get the exact value, but this should work. And just, I want to see these kind of numbers coming in. So we'll just debug print the current position. Or actually, there's a way easier way to do this. Debug print the list as soon as we're done. There we go. So script and play. 1 second in, we should have a full list printed. There we go. And there's nothing visually to see, unfortunately, so this is it. I know it's not great, but it's like, okay. So this is our 0 position, and then we move over by just a hair. So this stays the same, and this stays the same, but this is, so our x is the only axes we're changing. So it goes over by 0.07 and then so on. And it's just going to keep going by that amount until it reaches the end. And theoretically that works. Now, to test that, there's a few different things we could do, but I think the easiest is just to highlight the characters. And so we're going to write some simple code. It's not simple. This is going to be really difficult. I'm like a little jittery to figure it out, but because we have these start positions, we can now determine which position is the raycast pointing at. And so we go to our on update where we're doing our display update. We've currently determined our monospacing. We know that we want to display those characters, which we typed into our list of keys. We know that our keys displayed is going to be the ones that we're displaying. And so this display me is going to be, we need to set up our display me, which is a while loop. And so remember how I said we didn't need to put this right here? We were going to use this later anyway. So we're going to drag this down here and only use it down here. So what we do is we set keys displayed to keys, and then we run a while loop to remove items from the keys display until we get down to our display me. So display me's been set here. Keys displayed can be set right above that. We don't need to debug print the hit point. We're going to use that in just a minute. So then what we need to do is display this list using a while loop, and we're going to use a while this is greater than, so while the length of, we're going to go to operators length of list down under list section. There we go. So while the length of the keys display is greater than 0, I'm going to duplicate this number, backspace. There we go. So while the length of the keys display is greater than 0, we're going to add item from index 0 and then remove it to display me. So we set display me to be display me plus the newest character. So we'll go grab the plus symbol from the top of our operators and then drag display me to the A slot. And then we're going to go back down to list where we can grab get item from list. And the item is at index 0. So we'll drag that into here from the keys display list. And we're also going to grab remove item at index, which allows us to remove the item at index of 0 from the keys display list. So we're constantly adding to display me, and then we're able to display me on the text object. So this is basically now doing this. It's now displaying this string here, which is great. We've got our monospacing set up, which should be identical to how it's currently set up. Now what we need to do is make sure that hit point that is closest to the position is the one that we remove. So we're going to need to do another while loop. And I'm worried about this hitting the cap once we have all the characters in there. But for now, I think we're okay to just throw another while loop in there. So we'll go grab events tab, while. And what we need to do is after the keys displayed, So after we set keys displayed, we need to determine which key it is and then make it highlighted in here. And it's pretty easy to do. So let me show you. We need to determine the key. So we're going to create a new variable, which will be called highlight me. So this is the number that we want to highlight. And so after we're done running our while loop to determine what number this is, to highlight it, we set, so operators tab down under list, we set value at index in list, and the value we'll determine in a second. The list is the key display list, and the index is that number we're calculating, the highlight me number. And then the value is three things. So we go to our plus symbol at the top and then make a few of those. And then the center symbol is under our list function. We get item from list, put that in the A slot, and the item we're getting is the current highlight me. And then the left and right side is the highlight. And so we go to our string input, and then this is whatever we want it to highlight. So we're going to do bold for now. So we'll just do /b on the end, and then b on the front end, and then we need to add a slash on this side. There we go. So this starts the bold and ends the bold. And that is how we will highlight each key. So then the while loop needs to determine this. Now, the easiest way to determine a while loop, I love doing the running through positions, and removing positions from a list I think is the best way to do this. So let's go grab a new vector, which we're going to call highlight position. Ooh, that was slow. Highlight position. There we go. And go to the, we'll make this a list, confirm. Sorry, there's just this weird lag every so often that just you can't see because it's perfect for you guys, but on my side it's like, ah! Sorry, I hope that shaking wasn't too rough. That's how it feels sometimes. So we're gonna go set highlight positions. So similar to how we set the keys, we're also gonna set highlight position to the key position, and this allows us to iterate through the list. So we say while the length of the highlight positions is greater than 1. So once there's only one position left, we need to stop because that is our position that we want to go to. The problem being, sorry. I'm like figuring it out as I go. So what we're going to do is grab another set2. So we go grab set2, put this right after the while loop. So we're trying to figure out what highlight me is. So we're going to set highlight me to be, go down to the list, and you can get index of item in list. And so remember how we're going to save this current highlight position? It's the remaining item in this list. So we need to find out the index of that item in the original key position list. So we then say get item from list, and then that's the item in the highlight position, the remaining item, which is at index 0, because it's the last item in the list. So we set highlight me to be the index of the last item in the highlight position list from the key position list, which allows us to highlight it. So then what we're going to do in our while loop is remove the item that is not last. So basically we're going to do a comparison and then remove the item that is worse. So, oh gosh, this lag is killing me. So the thing we're doing is we're removing an item from a list. That's what we want to do in the while loop. We're removing it from the highlight position list. And the item we want to remove is whichever is the worst. And so what's cool here is we can set that value pretty easily. And so you go to, oh, will that work? I don't know if that'll work. I think this is going to give us an error, but it's worth trying. Yeah, it's worth trying. So there's a function that works great for numbers, but I don't think it'll work for, yeah, we need to do a distance check. So that's not going to work. So we'll come back to this remove item in a second. So then what we need to do is check the distance from the current hit point and figure out which one is less. So we say if else. Yes. So we're going to do an if and then an else. And then we'll go back to our remove item from list and remove item at index from list, where we have two competing items. And so it's either going to be remove item 0 or remove item 1. And this is from the highlight position list. So basically we're going to put 0 up against 1, and if 0 is better, then it stays, and if it's worse, then it leaves. And so the condition, I'm actually going to reverse these. So we're going to compete 0 against 1. So if 0 is better, then 1 gets removed. If 0 is worse, then 0 leaves. So we say if 0 is closer than 1. And so we take at the top the distance check of less than, and then we go down to vector math where we can get distance to, and then drop this into here and into there. And we're getting the distance to the hit point. So what we're going to do is create a new vector variable, which is going to be called current hit point. And so I'll call this CUR hit point. And this will allow us to use this value multiple times, and it just makes our script a little bit more efficient. When we're doing this much math, efficiency matters. So we're going to set current hit point to the get hit point from Raycast. We can then say, what is the distance to that hit point from the two current highlight positions? So we go back to our operators tab, down under the list functions, get item from list, and this will be position 0. So we're rooting for position 0 is kind of how this if statement is phrased. So we say, is 0 less than, and if 0 is less than, remove 1, otherwise, and then we have to put 1 over here, right? So then if it's less than the distance from 1. So if 1 is greater, then 1's got to go, and then else 0's got to go. And that should work. So I think we've got our highlighting set up, and it's just good to test. So let's go and see if we can actually highlight these keys. I'm not convinced, but here we go. Oh, it's working. Look at that. Oh, wow. That is working, isn't it? My goodness gracious. I didn't expect it to work so well. Wow, look at that. Oh, that's so good. I'm shocked. We do have an issue here on the end, but it is like working correctly. It's just not. Oh man, I didn't expect that to work. Did anybody expect that to work? What's cool though is it also works at a distance of up here, right? So this might actually, yeah, this has got some really good functionality. Now we do have a problem with our backspace not looking like a backspace symbol. So, and I don't really want backspace to work like a regular symbol anyway. So what I also want to do is we have this issue where when you move your mouse off, it's still highlighting. So we need to do maybe a don't highlight if not. So let's see, so many thoughts in my head. First of all, I didn't like backspace. Backspace was really crappy. So if we go to our keys list here, this is where we've drawn up our keys. I'm going to just, I don't know. I don't even know what to do for backspace. It's just there's no symbol that looks like that we can type in. Or is there? Is there a symbol? I'm on a desktop computer right now. Can I type from my desktop? Let's type in an L. No, it didn't work. Okay. So like there's a thing where if you're on a desktop, you can like copy and paste sort of a code using like an alt code. So I was kind of curious if that was going to work. Huh. Well, that didn't work. So people will know that a silly symbol could be a backspace, or they might think it's that code piece. So, well, if we don't allow people to type in codes, right? Ooh, or we type in a space and leave it blank. Just type in a space, leave it blank, because we don't have a backspace, at least not yet. So that should leave an empty space there. Okay, that's fine for now. I will live with that. Then the next thing we need to do is over here under our length of keys displayed, set display me. We only want to do the highlighting if we hit. And so right now we're doing all of the things under did hit. And so we want to do display outside of the did hit. And so it'll say while length of keys set display me. We also need to set display me here, and then we only do the bolding if that's the case. So we need to set keys outside of the if statement. There we go. And that should allow us to reset that. So let's give that a go. Go ahead and hit play. Come on in, grab this. So you can see this is what it looks like with no bolding. Then if I come down here, this is what it looks like with bolding. And that's what I was afraid of. So I kind of thought this might be why it was working so well, because the numbers were off by half. But you can see if I point 9, 0 goes off. And is there any that are good? It's like maybe that one's good, but they're just off by half. I've had this issue in the past, and I'm like, I was kind of aware it was going to happen. It's because we're off by half a space. Just half. You can see right on the edge there. So we need to calculate that difference by moving our start position over by just that amount. So stop this and then scroll back up here. So our start position was set with all of this fancy math, but there's a little bit off here under, is it the 0.5? So we take this position, we're multiplying it by 0.5, but we need to multiply it by 0.55 or something like that. So let's just throw in an extra 0.5. I think that might actually be all we need to do. So script and play. Oh, no, it's still off. I think it's more off. Oh, so it's the inverse of adding 0.5. It's 0.45. Okay, let's give that a go. 0.45. That makes sense to me. Please be right. Please be right. Yay, there it is. Okay, so now the numbers are highlighting correctly. Perfect. Okay, and that works all the way across. Fantastic. Okay, so good on our keyboard. That is great. So highlighting's done on our first row. So we could theoretically at this point pull our index trigger, and we would know that the item highlight me is the one that we were talking about, and we could send that through as a key press. Pretty good looking keyboard so far. So the last thing we need to do is potentially change our highlighting, because it's not highlighting well enough to be able to see it. So I think what we need to do is change the color to like blue. So we do color. Ooh, getting some lag here. This sometimes happens with text when you do a ton of text codes inside of a script. So I'm thinking that's probably the issue. So we're going to say color equals cyan. And then we'll go over here and do slash color. COLOR. And so what I usually recommend to prevent this from happening is to create variables with these codes in it, and that prevents the lag that you get. I'm not doing that right now because it's already too late. But anyway, so now we should get the highlight, but with color. Ooh, cyan might not be a color we can use. Let's go and man, I thought color would cyan equal. Well, we'll write our own cyan. So that's color equals pound, and then we do no red. So it's like, we'll type in 15. We'll type in A. There we go. Script and play. Hey, there it is. Nice. If I pull off, it unhighlights. So that is pretty good. Good looking setup. Ooh, question. Where's the 0? Where's the space bar? The space should have been at the end there, but I don't see it. Maybe that's what caused our numbers to be off by half. Oh, now I'm even more perplexed. Okay. Stop. Why is there no space in here? Spaces are probably being automatically removed somehow. So let's delete this one, add a new item, and let's just go with that backspace symbol right there. see how bad this is now that I've realized there was an issue. Yeah, so it's not fitting. Problem 1. Keys, totally accurate though. Okay, so the positions are totally accurate. The mostly accurate. I'm all over 6, it's working, but as soon as I get over just a hair off. I think our mono spacing is just a little too wide. So let's go adjust our mono spacing down by a hair, which is right here. We took 50 and multiplied it by that. And so we take this down to 40. That should make it just a hair skinnier. So we'll go ahead and try it out. Oh, that is way more than a hair skinnier. That is like way more than a hair skinnier. 45, I guess. I'm just shocked at how wide that was. 45. Did I play? I did. There we go. Okay, there we go. This is much better. I'm liking the spacing here. That's feeling pretty good. It's just not great there. So these positions are just a little too wide. And so I do like the aesthetic of this. It's just a little too wide. So we need to make the width of the keyboard like 0.95. The numbers come in a little bit. So to fix the width of that, set start position. So a lot of these, like this crazy math in here, is because we're really trying to make this usable by a ton of people, which is what makes it much harder to read. Because if you were just working with static positions and you just like, it would be so much easier to write this. We just throw in some random numbers and it would be perfect. So step start position, a position of this times, we've got the direction and we're multiplying it by the scale of this x. So this is where we need to take this and add another multiplier. So let's go ahead and duplicate this so that I can easily modify this. So right here's where we need to delete, and we need to multiply that by like 0.95. It's my guess. So x of, drag this number in just for ease of use, delete that line, and change that to 95. So 95% or 90% is what I'm thinking is going to be the answer to our mathematical quandary. 5, 6, 7, 8. So starting position seems solid. 1 is solid. 2 and 3. And then by 4, it's not looking so great. Because I think we need to do this in 2 positions. So we're using it there in the first position. So the first position is probably good. But then we use it again right here where we got x of scale for the modifier. So this is the second place it needs to be used. And there we go. So we could make this into a variable. So we're not calculating over and over again, which is probably worth doing. So let's go create a new variable called scale of, so it's a vector, and it's the, it's actually not a vector, it's a number. And this is the KBS width. There we go. And so by calculating this one time, we don't have to like break our while loop. Our while loop will run more efficiently, all of those things. So then set KBS width, and then we'll drag this whole line down. Also makes our script so much more legible. We'll scale over, duplicate that in here, and then replace this entire multiplier there. Booyah. So we'll give that a try. Script and play. Coming in. 6, 7, 8, 9, 10. minus equals. There it is. Perfect. Oh, that's working great. Okay, so we've got our positioning fantastic on our first line. And so now we need to add lines above and below. And when we create these lines, and I'd also love that you can kind of go down. That's kind of nice. I love that. So when we create these next lines, we need to do, in my while loop, we're going to have this basically be 3 sets. So we do adding above and below for each of those positions is kind of what I was thinking, but now I'm realizing that's not a great idea. So we should do one line at a time, then loop back and do the second line. And so basically we use the character count to create a modulus. It's similar to like when you're creating a timer. And then we need to move up by this KBS width up. Probably will do the trick. And then we can change our line height if we need to. So let's go back to our keys here and start creating the rest of our keyboard. So under keys, we've done the first line of our keyboard. So now we're going to do the second line. So second line, it starts with a tab, which I think we can represent as an underscore. I'm like not sure I really want to put a tab in there, but there you go. There's our tab. The next line is a Q, and we're going to do these all in lowercase. Q, W, E. It's going to take a minute. R, T, Y. I'm like realizing we could have written this out as a singular string. It's a little late for that though. Okay, we're going to keep going with the list. List makes it a little easier too, in some respects. Y, U, I, O, P, this guy, and then we had the backspace, which we'll do again, because that's apparently just how Horizon keyboard is formatted, to have backspace that looks like that. And that's our next 14 characters. So then after that, we go on to the caps lock, which we're going to reference as an up icon caret key for caps lock. And then we'll do the ASDF. G, H, ASTFGHI. I have a feeling our while loop is totally going to break, so I might need to come up with some better ways to while loop through this. GHIO. Oh no, I went to the wrong line. GHJKL. GHJKL. That icon. This icon. That one. And then we got the enter symbol. What are we going to use for enter? Maybe the opposite of the backspace, right? So there we go. And our next line, and then we also have to have shift keys. Oh man, I haven't done this in a while. And when we did it in the past, it was a little bit easier because we had so much more massive scripting in here. But I'm like debating whether we even consider having a shift key. Okay, so enter makes sense. We did caps lock with the up. Shift also the up symbol. It's just kind of like questionable. So we do maybe we're on the next line. So the next one is that one, but then there's 2 of those in a row. So another one of those. Then after that, we go Z, X, C, B. My God, I'm getting crazy lag right now. Like, it's like, I don't know, I feel like I'm crazy dropping frames. I can barely use my key or hands. V, and then it works all of a sudden. B, N, M, comma, period, slash. Now we've got arrow keys popping in here, which is, oh no, that's not an arrow key. That's another shift key. Okay. And after the shift key, we go to another enter, which we were doing with the to the right symbol. Okay. So then after that, we reach the like symbols key here. So we got the symbols, and we got the space bar, and then we got arrows left and right. Spacebar is just going to be its own thing that we're going to have to define as being below the keyboard. So I don't really know that I want to do symbols. There's definitely some symbols we're going to be missing. It's going to kind of suck not having symbols, although we could create like a upper row for symbols potentially, because that's the only thing we're kind of missing. Oh, I guess there's a few more symbols in here we're missing. Might have to work on creating a shift function, but for now, we'll go backspace this. And we're done. We've got, how many lines is that? So we've got the top one, it's 4 lines. Okay. Okay, world wasn't running. I was like, maybe it's all laggy because the world's been running this whole time. No, okay, we're good. So now we're taking the length of this. I'd like to start with the display loop. I think that's just an easier one to work on. And so down here under display, we need to add breaks on the 14th modulus of the length. I think that's all we have to do. So set display me to be this, and then get item 0, remove item 0. So when the length is equal to 14, we add a break. I'm pretty confident. We can just test it and see. So we'll do an if statement and equals symbol. So once you remove that item, so the length of this starts as 14 times 4. We subtract 1, so then it's 13. And so we need to know that this equals the character width count of 14. And then we're doing a modulus, which allows us to get the remainder. And so we say the length of the keys display modulus this value, which means this should return 13. And then when it returns, oh, it'll never return 14. It'll always return 0. So when it is 14, it'll return 0. And then when it's at 0, that means we add a break. So we set display me to be display me plus a break, which we'll go and type in manually. String input break BR. Okay. So now that we have the break in there, length display modulus character count width equals 0. The only problem is it will also happen when the list equals 0, which I didn't really want to happen. But what's the problem with an extra break? Because, hey, why not at the bottom of this, the very end, the last thing we do with that special break, just add a bunch of underscores. How many underscores do we want? We want 14 of these. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Sure, why not? Because that'll be our space bar. Okay. So we go script and play, and we're going to get something really gross here, but maybe? Oh, nope, we're running over execution count. That doesn't surprise. Entity provided the recast script does not exist. Script execution ran execution count. Yeah, so this is while loops. While loops are pretty limited in Horizon. They break really easily, and 80 is usually the limit. So you do this 40 or 50 times, and then it can only run 50 or 80 singular lines or something like that. So then having all of this in there is too much. Darn. It's also probably breaking up here too. That's my guess, because there's also way more keys. We could calculate some of this outside of here, which would make this a lot easier. Not sure what the answer is. Like, I know of a bunch of solutions, but I'm not sure, like, I want to implement those solutions. So we've calculated all of those positions. We just need positions that are up and below those positions, but we need them at specific indexes, which is part of the hard problem. So if we took our start position, recognize that there's now 5 lines. Okay, this is fine. We're not running the script. There are 5 lines. 1, 2, 3, 4, 5. And we could then move the start position up a couple lines and then add the positions below. But the problem is those positions aren't accurate. Can you add 2 lists together? That's a good question. Okay. So recognizing that this script is just broken right now. So even just hitting play is going to probably break. Yeah. But that's okay because I can pull out another script gizmo and just do some quick testing. Also want to delete this since we're not using it anymore. And then we're going to attach this script to this object here just for the sake of having it. Boom. Script 1 is now running. So when world has started, what we wanted to test is, can we add 2 things together? So we're going to debug print a new list. So we're going to create a string list called, yeah, sure. It doesn't need to be important. And then we're going to create another string list. And this will be A, confirm, and then we need B, so string list B. We want to add these together. So we're going to add an item to this, which will be, I guess, B. We're going to add an item to this, which will be A. So the question is, can we add those lists together to create CC? So we want to debug print CC, which we want to set. So we go and grab set to set CC to be this plus this. So we could grab A plus B. Can't add lists together. Nope. So we'd have to while loop through it to add them, which isn't the worst thing in the world. Our while loops are running at limit, which is why I was trying to avoid that. Can't add lists together. That is really unfortunate. That is really unfortunate. Okay. So now that script's gone, this isn't running a script anymore. Let's think about, what if we have 5 lists being created at a time? What if we had 5 lists being created at a time here? Because that would break this into 5 pieces, so the while loop doesn't break. It would break this into 5 potentially pieces, right? Hmm. Mm-hmm. Mm-hmm. While loops are the worst. Oh, okay. So, you know what? Oh, it's gonna sound crazy. If If we just switch this to local scripts have higher while loop limits. Script, clear, stop, play. Okay, it still ran over, but when I grab the object, I become the new owner and the script restarts. Oh, and it's breaking, apparently, so it's not letting me grab it. Build mode. Yeah. Apparently, it really doesn't like the idea of that. Never mind. So we'll go back to default mode because it was working great. Oh, what the heck? It didn't change to local. Settings. Oh, staying under default. Okay, well, I'll leave you under default. The world's not started. Why is that bugging out so bad? Oh, now it says local. Okay. Script and play. Nope, still not happy. Yeah, it's really not happy with that. I don't even know how that could be happening. Okay, so back to default. It says it's on default. What the heck? Oh, silly thing. And breathe. Oh man, my eyes. Let's think. I'm thinking I don't care enough about that to want to think about it right now. So I'm going to take script 2.0 offline. Keyboard 2.0. We're just going to detach you, which is unfortunate because of all the things that we had referenced, but detaching, ignoring it for a minute. Like just taking a step back, thinking. I think just like speaking out of the top of my head, I would go a different route. So I would start over, text. There it is, mega text. Okay, so mega text has this capability of doing amazing things. So basically, you take, I'm just like, quite literally would start over, and I'll show you why. So mega text is what we would attach to this script. Boom. Now mega text has this function where it's going to concatenate a bunch of things. So I'd like to start on line 3 with our mono. So you go m space, mono space, which equals 0.45 is what we landed on. And now that we've got that in there, we can then come down here to our next line and type in the entire top line, which was this. And this is way easier to do. Sometimes you just got to really take a step back. Now I'm not typing in the backspace, which gives me the next thought of, what if we left justified this? So we said align equals left, and now you can see why I added a couple extra lines at the top. So align equals left, and then we don't have to type in the backspace. We could build like a symbol for the backspace potentially, or we could do something else later. But for now, there's no backspace. And then the next line, we would skip tab. So we're going to type in a space, and then we're going to type in this whole line. Okay. Oh, but we needed a break. Forgot to put the break in there. So we'll go just type break at the end of this. BR. And then we'll do the same. Well, now we're just going to add another line. Makes it a little bit cleaner. Okay, so we've done the second line, and then we go down to our third line, which is got the cap. So we hit space again. Okay. And enter. Okay, and then we're going to need another break. And we're on to the last couple lines. So then we're going to do 2 spaces to get the capitals, and type this one in. And then we skip the last 2. Okay. And then we do one more break, and this is where the space bar would go, but I think we'll have a custom space bar, so we won't type anything there. Okay, so with that set up, you should be seeing, I have to hit play world, script, and play world. There we go. Nice, pretty keyboard. We can duplicate that and delete the old one. We can even remove mega text from this now that we've typed it in. Okay, and mega text is removed. So while we could do all the fanciness of like figuring out which key and then highlighting it, and that was pretty cool. It's pretty cool. I also think this is potentially a much better approach. So there we go. Now what we could do is take like a laser pointer and kind of like point it. We could even potentially put like, we could do some snapping things here where it like snaps to each of those positions that we define. And then it's kind of like hovering over that character to highlight it, which could work. There's room for a space on the bottom, your potential like special characters on the sides, space for all of that stuff on the sides as well. Looks good. Looks good. So now we just need to, from our script, have an actual space. Sorry, we just need to define the actual positions. So it's less of needing to define the whole keyboard. So I'm going to duplicate this script, archive this old one, and open this up, and then just call this KB2. And then let's think about a few of the things here. First of all, making sure this, no, wrong button. Making sure the script is not local. Good. The initializer does need to know some positions and stuff, so we might keep this. On update, we are not updating the display, so we don't need to update the display. So we can delete that. We can delete all of this displaying and highlighting. We do need to know about which key is being selected, so we might need that. So we can delete the set display. We can delete this whole while loop for displaying stuff. What we do need to know is which key is being highlighted. So perhaps we need a different text object to be referenced. And that text object would be a little display up here. And then we're going to go grab unlit black. So I'll go highlight unlit white, scroll over here, drop down to manual color slider for a really true black. So you'll see this looks black, but if you go to bold discovery and use this black, it looks gray. So I definitely encourage the manual color slider for the full black out effect. There we go. And then we can scale that down. And you can imagine this being like our little text display here at the top. Okay. Not bad. Not bad. A little better. Okay, happy with that. So then we need another text object, which we're going to actually duplicate this and then delete everything in here. And the only reason is so that we can have the same text size. So it's identical in size. So that's the main reason we're getting this. And so the goal of this, we might want to keep monospace, then is to display a character. So we want to use this to be our display. We probably should have this align left too, huh? Because that makes sense. No, we won't. I'm just going to throw that in the center. Pull that out. Okay. So for now, what I want this to do is I want this to tell us which character we're on is the kind of the goal right now. So we're going to attach the KB2 script. And then we need to know about the surface. So we know where the positions are from. So yes, we need this value going into KB surface, although it's not animated, so we can actually go turn that off. We do need to know about the text object in the raycast. So we'll go open up the properties of this text object, dragging that into here. Okay. And then we need to know about this raycast. We're going to have to zoom in. Raycast. Zoom out. Find that properties panel. Drag raycast into the raycast slot. There we go. Okay, so all the things are reconnected. It's all happy days. This is probably still labeled KB, I'm assuming. Attributes tab, still labeled KB. Perfect, so that'll work. And now what we want to do in our script is determine the position, which is a little bit more complicated, but what we can do is take our initializer and turn this into an initializer loop. So I hate while loops because this almost always happens to me. Like I always do something so complicated that while loops don't work. It's like they should have worked, but it doesn't. And so what we have to do is actually convert it into an if loop. And so what the if does is it runs the exact same check as the while loop, but instead it sends initializer to self over and over and over again. And we do want this to happen really fast, but I'm going to just do 0 seconds, which means it's going to take like 5 to 10 seconds to complete. But that's fine. Like it could go faster, but this is fine. So initializer received, if the length of the key position is not equal to length of keys, then we keep looping through until we get to the end. And length of keys is no longer accurate. What we actually want to do is define 2 things. We need to know the height. So we need to know the height and the width. We know the width is this character count, and we also know that the height is 5. So it's 0, 1, 2, 3, 4. 5. Yeah, 5 is the width. So you take 5 times the character width, and that's going to give us all of the possible positions that need to go in this list. And then we set the KBS width. We can do this on the world start event. So that takes it out of this initializer phase. We can also set start position in this initializer phase. And then this while loop, what are we doing every time we come through here? Well, we're adding to the start position. And so this is a good start, but I think we need to do some more stuff in here. We're going to clean this up a little bit. The first thing we need to do, though, is move our start position up an amount. And so you'll remember we were determining the position this way, but we also need to go this way. And you'll remember that the forward direction was pointing out this way. So we actually need the inverse, so the negative forward direction. And so if we subtract the forward direction times the width of 2, so there's 5 layers here, the center is here. So we need to go up 2 values, and then we'll go down using the forward direction. So this start position is a good starting point, but we need to adjust it by moving it. So right now the starting position is right here, and we need to move it up 2 spaces this way, which can be done by subtracting from the original. So we take start position and subtract. And so you remember using subtract because we need a negative forward direction. We also need to multiply this by the value. So we know we need to go up by 2 layers. So it's we did some math up here that was really good. Oh, right here, the KBS width. So KBS width is what we're doing for character space width. And I think we can do this for line width as well. The width, oh, the line width is a little bit bigger. We will freehand it using this 0.95 modifier, and that's a-okay. It's not perfect, but it'll work. So we need to take the forward direction and multiply it by that times 2. So we're going to need another multiplier. So then grab the number 2 for 2 lines is how much we want to move it up by. And then we need the forward direction of the KB surface. And then we need to put KBS width, this same math formula, but it's slightly different because the 0.95 is probably more like 1.15. And it's kind of hard to tell where it's at. Like we could change the line height, but I'm just kind of judging based off of like, this is about that. And this almost feels like 2x, like the distance from there is pretty intense. If I use my hand as a measuring tool, right? So that's 1. So then this is 1, but then if you did 1 here, there's like another half. Maybe it's a little less than half. So we'd maybe go with 1.75 even. Let's go try 1.75. Okay. And then, so we've moved our start position. What we wanted to do is then see if we got to the right start position. And to do that, we move the text object that we'd defined. So we move the text object to that new start position just to see where it's at. And the script is running apparently. So stop, clear. Why did that run off into the middle of nowhere? X of scale of times 1.75 times forward direction. So this is supposed to be the width, but then we make the width of each tile twice. And we multiply by the forward direction, and then multiply it by 2 because there's 2 lines, and we subtract that from the start position. Let's see what that did. Play. For some reason, it moves it up there. I'm guessing there's a piece here I missed. Forward direction. Is being multiplied by 0.45 here. Start position. Position of, so we take the origin position of the tablet, and then we add to it with the cross going that way, but then we multiply it by that KBS width. Because I thought of this as a different value. I see where I went wrong. So then we take KBS width, which is the width of the board. That's like the whole width of the board. And then we multiply by 0.45 because we didn't want to go the entire board length. Got it. Okay. So let's rethink this. Let's actually just duplicate and start from scratch. Okay, so we take the start position. Now on the start position, we need to go upwards. So that's why we're minusing by the forward direction. So maybe the last thing we do is multiply by forward directions. Let's go delete some of this. So we multiply by forward direction, which is giving us that direction. And then we need to do this by 2. So we need another multiplier, but by 2 of the width. And we know that the width of the KB board times 0.45, which was half the board, but we need to do it not by half the board, but by a 14th times 2 is kind of what we were thinking. So you take that KB divided by 14 gives you the number of spaces. So down here, you'll remember we have dividing by the KB character count, which is 14. So length of divided by character count. I thought we were multiplying. Oh, here it is. Now we're multiplying by KBS width, which kept that 0.95 inside of it. Got it. And then, so we've already scaled this down. So we actually just need to take KBS width and divide it by 14. So we just need the divide symbol. And then that should do the trick. So divide this. Oops. Forgot to hit the duplicate button. Divide this by, I'll actually go ahead and delete this one since we don't need any more of that. And then divide that by the character count on each tile. And now I think the position's right. We'll just quickly check. Where is it? There it is. So the position it came up with is right here, which is close, but I can see that it's staying below the surface, so it needs to go up on the Y. Interesting. We talked about this a little bit earlier about how the Y was off. It's not far off from there, but it's enough off that I could get confused with this. So let's stop the world. Let's try going a little bit further. So we talked about how we thought that it wasn't Y. So this is supposed to be 2 lines, but we're dividing by 14. So we didn't multiply it by that extra amount. So we're just going to use this number to be like 3.5. So like this is the equivalent of 3.5 characters is the idea. So hit play. And now this should be, okay, it's a little bit too far. So let's try 3 characters. And let's see, did that do it? That's pretty close. Like, maybe go with 2.5 maybe. See if that does the trick. Not sure why that isn't as intense as we were expecting it to be. Script and play. Okay, that seems to work. That's at the right position that's going to give us the correct check. Okay. So we've got a good starting position, which is what we wanted to do. So we don't have to move the text object anymore now that we know our starting position is in the right spot. Now what we need to do is add to this starting position. And so this is currently just going in a line across, which isn't terrible, but it's not giving us the thing is that's kind of like, if we have these saved, we can do an if less than or greater than, right? So yeah, so if and then else. This isn't making sense because I haven't said everything. Sorry, my brain catching up with words. But the thought is, we generate the positions for the first line, and then, so that's the first if. It says, if we're in the first line, generate positions using the original. Else, get this position and then add to it with the distance down using the forward direction. So I think that's going to work. So we'll go ahead and try this out. So we say, if the length of the key positions is less than the character count width, then we add just like normal. Else, we take the modulus of the length. So when it's equal to 14 is what it'll be. Then it'll be in position 0. And then we're going to add again, but we're taking the position. Let's grab another plus symbol from here. So then we're going to take the position from the modulus. I know this isn't making a lot of sense, but I'll show you what I mean. So we go down to list. We can get item from list, put that into the A slot. We're getting an item from the key position list. And then the item is at the index, which can be calculated by getting the remainder. So when you take length of key position and you divide it by the character count, whatever that remainder is. So if it's 14, 14 divided by 14 is 0. So this gives us index 0 immediately after this is done. So this is start position down. And then when it goes to the next item, it becomes position 1. And so this has given us as a base value the item that's at that index for that line. And then what we can do is add to it by multiplying with some similar values to up here, actually. We're just going to grab this multiplier, delete the cross product because we're not using cross, but we are using forward direction. So we'll grab forward direction and then multiply that by KBS width. But the problem with the KBS width is it needs to be multiplied by 1.25 based off of our previous number here. So 1.25 is what we want to type in because that's half of the 2.5. So 1.25, and then delete this, grab KBS width. And so we take forward direction, multiply by that, and add that to the key position. The only problem is this is giving us one line, but we need to give this lines times the current index, which isn't hard to calculate. So like I said, this is very similar to creating a timer if you've ever created a timer before. And if you haven't, no worries, but you could probably do a timer if you understand this. So quite easily. So forward direction times this gives us the length of 1. So then we need to take that value and multiply it by which line we're on. So we're going to take this line, put it into A, delete this now, and we're going to multiply it by the floor. So we're going to grab the floor, which removes the decimal points. So grab the floor and then take the current length of the key position list and divide that by the character count. So you think when this gets to 14, this is 14 divided by 14, which is 1. Then it becomes 15, which is still 1 because we remove the decimal with floor, until it gets to the second line, which is 28, and at which point it loops to the next line. And so it goes down a little bit further. So that works. I realize I accidentally grabbed this from up here. There we go. Fix that. There we go. Okay, so now we've got an entire list of the key positions without having to sacrifice the the while loop problem. So we fixed that. This will run as long as there is spaces left to be filled out. It'll also create spaces for the space bar, which is cool. So we'll know where that is. And what we don't have anymore is some of these kind of like specialty, like the keys displayed list. We're going to delete that. The keys list, we're going to delete that question mark. Maybe not. Maybe we won't delete that. This might be valuable still. We'll hold on to that. Display me. It's kind of still needed. And so what we want to do right now is display the current key. Oh yeah, so we did need that. So we want to display we'll set display me. So I'll grab set 2 and set display me to be the get item. So we'll go ahead and grab, I could get it from right here. I'm just going to get it from right here. Just thumbstick to the right to duplicate get item from list. And the list we're getting from is actually the keys list. So we'll go ahead and grab keys and drop that there. And then the highlight me from the keys list is what we're getting. And so we only want to do this while we're highlighting for now. So I don't think this is going to work perfect, but we're trying. Okay, so ABCD by default, and then it's going to change. Oh, it didn't change. Ooh, is there a bug somewhere in there? Okay, let's go find out why. Can't get list item. Expected item 0 to -1 got 0. The entity provided to the raycast block does not exist. The entity provided to the raycast block does not exist. Can't get list item. Expected item 0 to 1 got 0. I'm wondering if this just broke the script, but it seems to be just keep going. Nope, it's okay. It has stopped. The entity provided the raycast does not exist. What is this telling us? Let's go start from the top and read through this. It's not a very long script. We can just kind of take a quick peek and see where it's at. Also, hi everybody. Thanks for joining us. If you have questions, feel free to ask. My brain is definitely getting fatigued on this math problem here, so at some point we might go do something a little easier, a little easier to follow too. But I think we're really close to having the keys, which is the hard part. So we might finish this. We'll see. Okay, so when World is started, we're transferring ownership of self to server player. Okay, also gonna just quickly take a sip of this. Like I said, just a sip. Okay. So this ownership transfer we were doing because when you grabbed the object in build mode, you became the owner. And so by transferring it to the server player on world start, it behaved like it was in publish mode, which is important. And so otherwise it was behaving like it was not in publish mode. So then we're setting the KBS width to this value here that we've calculated. We then set the start position, which we've calculated twice. So we calculate it first to the left, then we calculate it up. And then when initializing, oh, we're not sending initialize to self on world start. I guess I forgot to duplicate this down here and instead got it. Okay, so now we send initialize to self. And I want to send that with a 1 second delay. Give it a second. Okay. And then the initialize loop is going to go ahead and add positions to the list. Now that should actually happen. And then when on update is received, so after somebody grabs it, now this should take about 10 seconds. So maybe we'll do an else here just to know when it's done. So else when it's completed, let's just debug print. It's going to be a really gross debug print, but we're going to debug print the entire key position list. Why not? Okay, and then on update, as long as the owner is not server player, we can then fire the raycast, check for did hit object, do all these things. Okay, simple mistakes. Let's go. Okay, so we should see a giant printout here in the next few seconds, and I'm debating whether we speed this up. There it is. Okay, so those are all of the positions that it calculated. Well, let's go into play mode and try it out. So I've grabbed this. Pointing, I'm not getting anything. I bet we're running over the while loop limit because we're using a while loop to do the check. Yeah. Nope, that's not it. Why is it giving me issues with the raycast block? Script execution ran over an allowed instruction count. Okay, so we are running over the instruction count as well. So we got two issues happening in here. So issue one, we're raycasting with raycast. Is raycast filled out in here? It is filled out. So, and it says it's a raycast, so it should work. I don't understand why that's not working. Then we say did get hit object on raycast, and then get the hit point from raycast. So we're checking to make sure it did hit an object. We're checking the point that it hit. We're then setting highlight position to the key position, so that way we can remove items from this list. We're then doing a distance comparison between the two of these to figure out which one is the furthest apart. And then we set highlight me to be the index of get item 0 from highlight position. So basically we figured out which item needs to be highlighted. But the while loop is breaking because there's just too many positions in the list. I've done some tricks in the past to do like more efficient, like there are ways we can make this more efficient. Let's see. How can we make this more efficient? The highlight position list has 56 items in it. So if we could cut this in half, it probably won't break the while loop. Length of highlight position, although there's actually more in the width, isn't there? If we take this width down to 4, rather than, we don't calculate all the spacebar positions. We only calculate the upstairs positions, which will prevent us from being out of index as well, now that I think about it. Yeah, let's actually, if length, oh, this is using a not equals to. That's strange. Like, oh no, I see what it's doing, because it was doing an add. I understand why it was doing that. Because it is doing add. Let's actually delete this and let's check the length against the length of the keys, basically pointing out that these lists have to be parallel, so that makes sense. Make sure the world stopped. Okay, it is. So that should make sure we don't go out of index when we do try to call for this, getting an item from the list. Now, this distance check, to make this more efficient, what can we do? What can we do? Let's see. We check against 0. We could just duplicate this and do it twice, but I'm not sure that that's the right solution. Like, will that work? I mean, it shouldn't. There's no reason that should work, but I guess we'll try. Like, okay. Just do twice as much in the while loop. I don't recommend it, by the way, because that's not how while loops exactly work, but there's supposed to be... Okay, no, it's still breaking. And the lag I'm getting is absurd right now, because I assume all these while loops just causing it to go massive lag. So checking here, execution running over allowed construction count 99 climbs. Okay. This is because it's doing too much, right? Like it's like there's too much to do here. I can't do it all. And just doubling this isn't the way to make this more efficient. So what I've done in the past would be to build like another if else. Let's try an else if in here. We'll try a couple else ifs. This is gonna be nuts. This shouldn't work, but it might. It's not as gross as the previous design. So basically we say if the distance from this first one is less than, we know that item 1. So we know that if the distance from item 0 is less than the current hit point, greater than distance, we know that item 1 needs to be removed. Then we duplicate this into here, because now we know for sure item 0 needs to be removed. Like if this doesn't work, we know item 0 needs to be removed. So then this one says, okay, item 0 isn't good. Let's check if item 1 is good against 2. So now we're competing 1 against 2. So we know 0 is bad. Well, now let's check if 1 and 0 are bad. And so then if it's like, oh yeah, 2 is way better than 1 and 0, then we have to remove 0 and 1. And then probably a better way to do this, so we're gonna have to look at that in a second. Then we do one more of these, because why not? And then we say, okay, what about we try, if that's not true, then we know that 2, or wait, no, this is, I did this backwards. Sorry, we do need to type in 2 and 3, but let me figure out what I'm thinking again. Okay, so you've got 1 beats 0, so we compete 1 against 2, and if this is true, then 1 has beat 2, which means we delete, yeah, then 1 is beat 2. So we actually want to compete 2 against 1, huh? So then we do 2 against 1. So now if 2 wins, then we're deleting 1. 0 and 1. So now we know 2 is the last one left. And we go on to the next one, which is going to compete. And I guess we'll put this in reverse order. So we say 3. If 3 is better than 2, so we just keep walking up, trying the next competitor. Got it. Okay, this makes sense. Then we do 0, 1, and 2. Okay. So 0, 1, and 2. And the else statement here is if 2 beats 3. No, I feel like there's a couple more else's in here, right? Like, because 1 could beat it. So, okay, let's start from the top. So 0 beats 1. 0 beats 1. Then we run on to the next check. We got to try 0 against 2. Oh, this is way too complicated. We're deleting this. This is too much. Just go back to the basics. Okay, sorry guys. There's definitely a way to do this. I'm just trying to figure it out. See, in the past, I'd be working with individual numbers because we are it's distance, right? Like we're working with distance, and so basically you'd plug in one of these from the top of your math tab. You've got max and min, and you'd be like competing them with max and min. So you could do more than just 2 comparisons per iteration of the while loop. The other thing is we could just stop the while loop by earlier. And I think I've done this in the past and I think it's worked. So let's duplicate this down here. And let's compete the while loop for the first 25 iterations, and then we'll run a second while loop for the final set of iterations. If this works and it's that simple, I don't think it's going to be, but okay. And let's see, how fast is this loading? This is not fast enough. We're going to speed that up. Okay. Next up, checking. Oh, it's still running over a loop, but it's not lagging. So whatever I changed is a lot less laggy than before. So that seems good. So the issue we're getting is still execution ran over allowed instruction count. And then we receive entity provided to raycast block does not exist. I feel like this is somehow related to the while loop breaking. So yeah, I didn't think that would work. I think it did at one point where you could like have multiple while loops, but it's not a thing anymore. So gosh, I wish I could fix this. Hmm. What if instead of doing a distance check, we do a different distance check? So we say, if the distance from this item to this item, not less than. See this? I think this might I'm kind of excited. This might be the answer. So if the distance from this item to the current hit point is greater than 0.5, not 0.5, it's like, how close are these things? These things are really close. So it's got to be like 0.15. So if you're like within 0.15 distance of the item, we need to exit the while loop. So remove item at index 0 if it's greater. Else, we need to exit the while loop. So we need to go create an else that can clear us out. And I don't know if there's a way to do this. Oh yeah, there is. So we go grab clear list. So there's a clear list function, which is definitely going to get us out of the while loop because the while loop's checking to get down to one item. So if length of highlight position is, or excuse me, just clear highlight position list. And then we need to know the item. So every single time we come in here, so we'll go ahead and set this up to go to 0. And then we're going to set the highlight me. No, that's not it. We need to set a current vector. So I guess we need to create another vector. That's fine. So we'll call this while vector or something like that. So like we'll call it I vect. Note, I use I for our while loops, so that's how we know it's for the while loop. So set I vect to get item from this list, which allows us to save that value. So then when we clear the highlight position list outside of here, we were going to use the index of that item, but we can just use ivect because that's the final item. And that could potentially work. Not convinced. It's not as simple as I thought it was going to look, but it might work. We'll go ahead and hit play. And so to give this the best fighting chance, also I think it'll change to ABCD when it's done. So to give it the best fighting chance, what I want to do is I'm going to start over here on the left side because this is where the start of the list is. And hopefully it's going to give us the best opportunity. Okay, I've grabbed it. I've got to come in here really, really fast. And oh, it's working. Okay, so because we're in the beginning of the list, it's working. The positions are wrong. Like it's not getting the right value. It thinks this is 5, but it's not. And it thinks that's the far end. I wonder if the distance is just not accurate enough. So it's always gathering the item to the left. So it's not about the hit position being wrong. It's just the accuracy because it's comparing starting at the 0. Like, of course, this is right. So now let's go down to Q. Oh, and it broke. So this is, oh, no, it didn't. It's still too close to those values. So we go down. What? So is the while loop breaking when I go down this low, but it's still functioning well enough that up here it's going to work? Interesting. So the while loop is definitely not long enough to get the Q. Huh. Okay. Let's go see what's happening in this debug menu. I'm going to stop the world. Okay, script execution is running over cloud instruction count. No surprise there. And it's just doing that a ton. And whatever this raycast error is doesn't seem to be causing any issues with the raycast. I just think that has to do with the while loop breaking is causing the issue. So that was cool. That was pretty cool. So theoretically, if we make this a little bit more accurate, let's cut that down to like 0.05. We might actually get more accurate readings. We'll just try that first and foremost. And then maybe we can build some sort of matrix. Oh, that's it. Oh, that's it. It's The numbers are right. 4, 5, 4, 5. Yeah, there we go. Equals, minus, equals. Nice. We can't go down to Q, which stinks, but we can get all the way across this. Wow. Wow. Okay. First row. Let's go. Very happy with that. Oh, man. And of course, all the issues that we still haven't solved. But the question might be, is there a way for us to check the subsequent lines? So that's the question. Like, I don't know. I think if I was smarter, I could check the parallelness of a vector. So basically, you would take the vector and do some crazy math. I'm not smart enough for that though. I just like doing distance. Is the distance close enough? That works. Because I'm like, what if we plotted these points into a graph and then we could just normalize it as like divide by 0, 1 to find the position? So rather than doing a while loop to find the position, we take this and throw. Oh, that could work. I hate that that could work. So much work. Oh, my brain. My poor brain. Let's see. I think this battery probably needs to be pulled off, huh? Yeah. New boy. Let's go. How much power do I have left? Does it say? Oh, it doesn't say on here. That's okay. Just if I could do it with the 4 lines at the same time. Let's try something. No, I don't want to do that. I really don't want to do that. That's so much work. If we broke this out of a while loop and into an event loop like we did up here, which by the way, I said I was going to speed this up, so let's speed this up. So this sending an event with 0-second delay is not the fastest way to send an event. You just send the event to self without a delay. It is actually like 6 times faster. So this is going to be really, really fast. So you remember that starting time used to be like 6 seconds. Now it's going to be probably, yep. Yeah, it was about 2.5 seconds. Much better. So definitely isn't going to be as bad. So the thought was, well, what if 2.5 seconds? That's pretty bad. We could run it locally on their headset potentially, but the local script was really not happy with us a minute ago. Maybe because we were using def on update. Okay, let's think about this from the perspective of, could we define the position by calculating it relative to the others? So when we get a hit point, if we know the starting position, we can calculate the difference. We do have to rotate the vector plane. But if we get the distance up to this line, which I believe man, I've learned so much over the years, you guys. Like, this stuff didn't come overnight, but like, my goodness, it's worth learning. So like, I learned that the dot product is basically casting a shadow. You guys might have seen this. It's actually being used in one of the asset library assets. No joke. It's called Boombox, right? If you pull out the Boombox, here it is. Okay. This Boombox has a very cool setup in here. Let's go ahead and play script and play, where you can see that when you grab this and let go, it is being attached to this. Now, when I originally scripted this, it had to be flat on a wall because it was just grabbing the position that it was let go at. But this new version can be any angle. And most people don't know that. So I'll show you what that means. What that means is, if you grab this and you grab all of these little pieces, I think you have to grab all of that. Okay. Then we scale it, put it like that, script play. We come into the world. Now, this is at an angle, so the height is way higher, right? But you'll see it's casting it down. It's not working, actually. I wonder if this is because I scaled it to be super small. Let's see, if I go further up, does it work? Oh. Okay. Oh, man, it crashed. Seriously? Sorry, guys. Horizon just crashed. Classic Horizon. Shouldn't be surprised at this point, but basically, what you were seeing there is the issue was the very last thing that happened. I mean, you might have seen it, but it was like I let go way up high. So because I had scaled it, it scaled, but it didn't scale the vector that we were casting to. Oh my gosh, saying casting sounds weird. But basically, you create a plane, and then you use the dot product to cast a parallel vector to find out where it's at. It's weird. I don't fully understand it. I understand it enough to use it, which is, I guess, enough. But it's like, it's weird. So the idea that I have is if we do the same thing to our item there, we can determine where this hit point is on this plane. So what we saw as the last thing is that if I put it up high, imagining that this went higher, it does cast to the right position. So I think what I have to do, unfortunately I can't undo, which is unfortunate, but I can eyeball it, which is that it was roughly this big, roughly. So we'll come over here. And the really cool thing about this, though, is it doesn't have to be in a perfect angle. Like, I can just turn snapping off, rotate it like that, and it should work. So, we grab this. Oh, I realize you guys can't see. Sorry, guys. Bum, bum, bum. There we go. 3, 2, and... Ha! And there it is. Okay. So, what you can see here is even at this really awkward angle, it works, and it's basically it's just snapping it to this vector by using some fancy math. It's pretty cool. It's pretty cool. It's hard to understand, but it's pretty cool once you've used it a few times. And I've only used it once, so I need that few times practice. So I guess we'll go give that a go. Bye, Boombox. You were cool. Thanks for coming with us. Okay, so might have been good to open up that script and just show you what I was talking about. Now that I think about it. And maybe good for my reference. Okay, maybe we'll go back and look at it. Asset library. Boom. Box. Also, shout out to Wafflecopters, who is the genius behind all of this math. He taught me math so many times. Cannot thank him enough for all of the math lessons I've been in with Wafflecopters. Okay, so let's go down to when object is released by player. I guess we're on the wrong ones. This is the boombox. We need to know about the volume control. There we go, volume control. Okay, so under the volume control, when the object is released by the player, we set volume to be the dot product, which sounds very complicated, but we'll explain it more in just a second. And then we normalize the position minus this position. So these are the max and min positions, which are a position here and a position there. So we subtract those to get the distance between the two. And it's normalized, which is interesting. So it's actually not getting the distance, it's getting the direction. So you take this position minus this position, and it gives you the direction. And so that's what that is. This is a direction vector. It's normalized because it has to be normalized to be used in a dot product for what we're using it for. And then we take the position of self, which is the object you're grabbing onto and releasing, and then we subtract the minimum position, and that gives us an angle. So let me see if I can draw this up visually so it makes sense. So imagine you have a graph. This is a decent looking graph, really. Rotate that. So, and because we're in 3D space, our graphs. Whoa, yo, you're fine? Fine there, bro? There you go. So because we're in 3D space, we need to think about this being three-dimensionals. And so we take some positions. Let's go grab a position. Then we'll duplicate this and slide this over. And then we're going to grab this and make this really thin and snap it into here. Okay. So this should help us kind of talk about our thing. So this is the line that represents where the volume control is. So that's that volume control. Then we need a secondary line. I'm going to ungroup this, delete this. So you have then the position that you're dropping the object from, right? So this can be anywhere. You can let go of this object anywhere, but we have to let go of this object somewhere. And so when we let go of it, we'll say right here, we want it to project itself onto here. So when you take the dot product from here to there, and make sure these are normalized, which I'll explain in more depth in a minute, but you can then use the dot product to cast onto here. And I know that doesn't make a lot of sense, but it works, okay? I think that's the big thing that you need to take away is I might not be able to explain it very well, but it works and we'll show you how to use it here. But so what's cool about this though is this works at any angle, right? Like whatever angle that volume control is at, this will cast onto, and because it's just using this as like a thing. So now let's talk about what the dot product does. And now that we kind of understand this piece, so if we grab an arrow and another one of these line pieces, when we plug in a vector is more than just a position, right? Like it can be so many different things. So when we think about a field like a position, so say this is 0, 0 in your world, and then you can go out and all these, like that's 0, 0 right there, right? So you can go across your grid, you can go up. And so when we provide it a position value, most of us think about vectors as being a position, like this is your start position, 0, 0, 0. This is another position. But if you went and looked from 0, 0, 0 at whatever this position is, that is looking in a direction. And so when you start to think about vectors being a direction, this position, looking from here to there, this position is a direction in this direction. If you take this same vector and multiply it by a negative, and you make it over here in the negative space, now it's a direction pointing in the opposite direction. And so you can think about positions as also being directions from 0, 0. So if you take that value, we'll get into that in a second, but basically let's continue talking about this dot product here. So we've got a direction pointing out to here. And then say you have another object over here, and you want to know, is this position pointing in the same direction? So say, for instance, there's something here, but you want to know, is whatever this is pointing in the same direction as that? Well, the dot product is going to tell you that. And so when you plug in two values into a dot product, it tells you how parallel they are. And so if they're pointing in the same direction, it returns a 1. This will return like 0.8. And then if you do a 90-degree angle, that's that's 0. And if you do the opposite direction, pointing exactly opposite, is -1. So you got 0, you got like 0.75 or 0.747, I think is the actual value if you go 45 degrees, and then so on. So that's what the dot product is returning. That's when it's normalized values. Okay, so that's basically the basics of dot product. The other thing that we can talk about here really quickly is thinking about these positions being in space. And so when we have two positions in space, here's 0, 0, but if we want these to be relative to each other, we can take this position and subtract this position. And by subtracting this position, this is now 0, 0, right? Like now it's oriented around itself. So with our keyboard, we want to orient it around itself, which is why we're going to subtract the starting position. Okay, I think we've covered all the math, and I can actually go get into the scary stuff that I don't really know what I'm doing. And we'll give it a go. Feel free to pull this out from your yeah, feel free to pull this out and like tear it apart some yourself and try it out. It's just in the asset library there for you. Okay, so we want to know this. We want to know where it is along this vector. I'm going to grab some more just kind of like pieces to kind of understand myself as I'm thinking about this. So number one, we need to figure out where it is along this vector. I'm just going to put that there. And then number two is we need to know where it is along this vector. And so when we dot product against this vector, we can determine which row is it in. And then when we dot product along this vector, we can, this vector will determine row. This one's column, this one's row. Anyway, once we get those two things together, we're going to have that information. Now, the interesting thing here that's nice is we don't actually have to calculate this vector like we did with the position top and bottom for the volume control, because this is our forward direction. So we know this vector right here. That one's just get forward direction of object. And we know this direction is the cross product like we did before earlier in the video. So we can create these very easily. So that's the good news. Now the bad news is determining where it's at along that vector. How do we do that? So we take this position and we need to determine where it is along this vector. So do we have to somehow remove an axis, which I think is where we need to rotate this and orient it with the world? Just trying to think if there's some better way to do that. We find the position. I shouldn't have deleted that thing. I could have used that. So take this vector pointing this way, then we have the position. Doesn't matter where it's let go from. It's going to give us where it is along that vector, I think. Well, we'll go ahead and just debug print some numbers. So this is where I like to pull out another script gizmo. Just try plugging in some numbers and see what we can come up with. And if the numbers work out right, then I think we're on the right track. So let's go and grab this attached script 1. And I'm feeling confident enough to go ahead and delete keyboard 2.0. So now script 1 is attached. So on world start, we want to just plug some numbers in and debug print them so we can see what's happening. And so we're going to play with this guy as a thing. So this is our 0. It should be at 0, 0, more or less, right? So attributes, it's above 0, 0 by 1 meter. That's fine. Everything looks good. So this is a good guy to use. The Y value is pointing straight up. So we're going to pretend we're working on this axis first. So what we want to debug print is the dot product. So we go to basic. Is it basic math? No. This is going to be vector math, huh? There it is, vector math dot product. And so in our dot product, we're going to grab from object the upward direction of self. And so, whoa, no, please don't lag on me. No, Horizon. Horizon. We'll reopen Horizon and we'll be back over here on the computer screen in just a moment. Thanks for bearing with us, guys. Also, just noticing some chat. Have I not been getting these messages? Or did you guys just start messaging? You must have just started messaging. Because I'm like, wait a second. When did you all join here? Hi, Tyson. The video quality is choppy today. Really interesting. Huh. Orby. Hi you all. Hi Bree, hi Sushi, hi Shoes, hi Rainmaker. Oh, I know, next week Meta will launch a keyboard, right? Wouldn't that be amazing? Honestly, that would be great. I would be so much happier with that than having to like have you all try to copy this. But it's a fun thought experiment, isn't it? I mean, think about like all the math we're plugging through here, and like there's just so much to learn. It's great. So I'm gonna move the chat window back into the front of us so I can actually see your messages coming in. There we go. And that seems good. And for some reason, these keep getting reoriented. I don't quite understand why, but we're back. Okay, so what we were doing where we left off was we were plugging in upward direction of self into the debug print. Is the world stopped? Make sure it's stopped in case that's what's causing some of these Nope, it has stopped. I don't know. Okay, so debug print the dot product of the upward direction of self. This is running on here. So then we want to get the position of self, which is 0, 1, 0, and see, we'll even just type this in as a vector input. So 0, 1, 0 is the position that we're going to be imagining that this raycast is hitting. And the returned value is, please, drumroll please, 1. It returns 1. Why is it returning 1? Because they're perfectly parallel is the problem. Okay, so what if they're not perfectly parallel? If we type in like 0.01, what do we get? Still getting 1. Interesting. I see what's happening here. Oh, I totally see what's happening here. So remember, dot product checks the parallelness of a vector to another vector. So we have this vector going upwards. Then we have this position at 0, 1, 0. And so what we're trying to find out is where along this vector it's at. So the vector goes from 0 to 2. Oh, we need to also normalize the vector. Got to make sure to do that. And then this comes out of here. So this is 0, 1, 0 is what this is. And so we're trying to get the halfway point. So my concern is that it's not normalized, but it's not coming out at the right angle. Oh, because we didn't subtract the position, right? Like, okay, got it. So let's duplicate this, make sure to stop the world. Stop, clear. And we need to subtract the base position, so 0, 0, 0, which I guess isn't going to change anything, which is why we were using this at 0, 0, 0. Now that I think about it. Let's just keep chugging away here, but we need to normalize the vector anyway, so let's go grab the normalize. And we'll try some things out and see if we can't get it to work. Normalize. So we take the upward direction of self, and we're going to normalize these two vectors subtracted against each other. Plug this one in here, and 0, 0, 0. And I think I've got this in the wrong order. But let's just see. There's no way that actually returns the right value, right? Yeah, that's totally off. So that just returned -1 because they were in the wrong order. So we'll plug this up here, plug this over there, put this over here. Okay. So this is to be the starting point. And then what we want to do is imagine that this is coming off of the body by 1 meter. And hit play. Now we're getting 0.7. Which is exact 707. So I said 747 earlier, but it's actually 707 is the value. So that's that 45-degree angle. So why is it casting like that? I guess maybe I'm casting it wrong. Maybe the 0, 0, 0 isn't where I cast it to. Maybe I have to cast it to the center of that vector. So that would give us the value. Like I am thinking that would give us the value. So if we say 0, 1, 0, and then you hit play, we should get 0.5. Return 0. Why did it return 0? Because 0 is 0.5, right? Like 0 is that midway point between the two values. Okay, we've got it. Okay, we've solved the math. Thanks for bearing with me, guys. So we've solved the math where basically we need to take the center point of this and subtract the hit point. Man, this is some craziness. And then it should work. Oh, this is so refined. Oh, I'm so scared. And then all we have to do is multiply those together at the very end. It's not that hard. It's not that hard. I swear it's not that hard. Okay. So highlight me is no longer going to be the index of I vector. Highlight me is going to be, and I guess the interesting thing is here, we won't need that vector list anymore once we do this. So that'll be kind of interesting as well. Yeah, let's go delete the vector list. This makes our whole script so much easier. Ugh. Delete I-vect. Delete highlight position list. Delete start position. I think we'll need key positions. We don't need. Okay. So we can come up here and we don't need anything from the initializing. Yay! Delete the initializer. Okay, we've saved the start position and we're making this script even easier. Now we can go delete all of these. So we set the current hit point. We don't need to know this. We don't need to do this whole while loop. And highlight me is going to be two values we need to calculate. So value one is row position. Actually, let's start with column position, then go row. So column, C-O-L-P-O-S, and then row position. And then we multiply those together to get the index. Because 0 times 0, 1 times 0, well, that doesn't work, does it? You don't multiply them together. You don't multiply them together, no. You get, how do you do that? Well, I guess you never have anything in 0, 0. Well, you could have this in 0. What? I see how it is. I know, I figured out what I did wrong. Okay. It is multiplying and plussing. So you add two values together, and those values are the current column position. Let's start with, I think you just add column position. Yeah, you just add the column position at the very end, and then you multiply the row position times the characters in each row. And that gives you the index of that item. So column position, yeah, that's exactly how that works. Cool. Okay, so with this setup, we've now figured out how to calculate highlight me. Now we need to determine that by setting these values. So we're going to need to set both the row position and the column position. We're going to do one first and then do the next. Let's start by doing the column position. No, we're going to start by doing the row position because that's the easiest one. So row position, and that is divided by with a floor. So we're going to get a floor. We need to divide by the number of rows there are. There's going to be 5 rows. We're going to type in the number 5. Yep, so divide by 5 to determine which row we're in. And then we're getting the floor, so we actually need to multiply by 5, right? Right? Come back to that in a second. I'm going to duplicate that down here for now. So the dot product is going to return a value between -1 and +1. We multiply that by, yeah, we're going to need to multiply that. So multiply that by 2.5 will give us a value between -2.5 and +2.5. Then add 2.5 to that. Now you've got a value between 0 and 5. And then just get the floor of that. So we don't need to use this divide by, we just need to multiply and then get the floor. Okay, so we're multiplying by 5, no, 2.5, 2.5. And then we need to add to it. So let's go grab a plus symbol. And we need to add before we multiply. Yes. So it'll be a number between 0 and 2. Yep, that'll work. Okay. So then that's going to be the dot product there. And then we add 1 to it. Add 1. And then we just need to plug in the dot product of the forward direction of self. And now forward directions and upward directions are always normalized by default, so we don't need to throw the normalized in there. We do need to throw normalized into the next spot, where we go and grab, where's our normalize? There it is. So then we do need to normalize the hit position minus, so we'll go grab the minus symbol. So current hit point minus the center position of our tablet here. Man, I hope this works. So, and then we got to get position of object in the KB surface. Okay, so that should give us our correct row position. Then we duplicate this into here, where we can do the same thing, but instead of multiplying by 2.5, and we're going to multiply by 7, right? Because that's half of this. So 2 times, this would be 7. Could have done some other stuff. This is fine. So normalize current hit position minus position of that. And then forward direction is not the one that we use for this dot product. In this case, we're using the the cross product is how we get that. So there we go. And now I think we're good to go. This is crazy. I don't think it's going to work, but it's crazy. We'll give it a try. Can actually delete this script now. Bye script. Thanks for being here for us. Clear. And join the world. This isn't going to work. I'm like too scared. Okay, we're getting outputs. Not the right output. Not even close to the right output. But we're getting outputs. Let's try to get some letters going across here. Feels like these things might be reversed. Let's go and oh, it's getting some crazy errors. Instead of displaying the get item from index, let's go and comment this code out. Can we comment code out anymore? Is that even a thing? Let's be able to do that. Nope, can't comment code out. Darn, that'd be cool if we could still do that. We can use debug print to save this for later. Got it. Debug print that. There we go. And then what we wanted to do was just display these values. So I'll go grab a plus symbol. And then we should really put a space or something in there. So maybe we need a couple plus symbols. Okay, that'll do. String input right in the center. Which will be a, I don't know, an underscore maybe. That's fine. And then I guess we really only need that. And then we'll do variable is string. Put these on the left and the right. And so we'll do row on the left, column on the right, and script and play. Okay. So it says we're currently on row 1, position 8. That looks accurate. That sounds almost perfect. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. It's one off, but that's really remarkable. Okay, so it says 0 over there. Like, now it's at 1. There's something weird happening here after 8. I don't know what. That was remarkable, though, for most. Now we're on column 2. The rows are working perfect. Or, no, they're not. 1, 2, 3. Can't go to 4 for some reason, or 5. Doesn't know how to get down below 4 and 5. So just checking. Row 1, perfect. Row 2, almost perfect. It gets a little bit off over here. And row 3's completely off, or 3's good in the center, but it's bad along the edges. Yeah, I have a feeling I can kind of guess what's happening here, but so close. Why? 13's. Oh, I have the cross product in the wrong direction. Stop, clear. Ha! Okay. So this cross product we used here, where we put this goes to here, and then this goes to here, but this is out this one. Okay. Script and play. Okay. So now we should be getting 1, 0. Oh, it's not getting me 1, 1. Why? It's a little more accurate on this side. Didn't get to 14, did it? Got close, though. Didn't get to 3. Got really close. Oh, it got really close. Really close. Okay, I kind of want to plug this into the, bring back that code we had written right here. Debug print. This. Maybe we'll keep that around for now. We'll keep this in case we want to get back to that, because that was valuable. And play. Okay, here we go. So we should get underscore Q. What the heck? This is reading the bottom row, isn't it? No. It was so accurate with the number it was providing, but for some reason here these numbers are off. So somehow the index of the item we're getting is just wrong. I could have done my index wrong. This was pretty accurate, especially around the center ones. There's something off there. Okay, let's take a look and see where I might have made a mistake. So we were getting the item highlight by taking the row position and multiplying it by the character count width. Which makes sense. Oh, but it's calling that row 1, not row 0. Well, that would cause a massive change there. So let's just go grab a -1. Just throw that in there for funsies. Row position -1. Okay. And then we add to that with the column position. Let's go try that. And play. Hey, that's the right one. These are not far off. They're like, it's not perfect, Avi, but it's like on the right track. It's interesting because you can kind of see it slipping through in this really condensed area here. A feeling think I can see what's going on. Like it's very clear to me what's happening here. So to quickly tell you what I think is happening, I don't think it's casting correctly. So when we think about the dot product, remember how it gives us that position back. So I was taking this center position here. This thing does not let me hold it how I want to hold it. There it is. So it's taking this center position here. And then the hit point right now is like right there. So any direction, just small direction, is crazy massive. Okay. So I don't think it's casting it the way I was expecting it to cast. First line works pretty well, which I'm shocked by. Second line works pretty well. And this, I mean, that one was the one that we did the most testing on. It's not terrible. Just, I don't know. I might have to break. Oh, there's a big old Nalia in that screen there. It's adorable. Hi, Nalia. Oh, you're trying to look back at me. I was looking at you through that screen. Hi. So yeah, I might have to just take a break on this, but I think there's just some projections going wrong here. I almost kind of wonder if we I almost kind of wonder if we could like get some value from here when you're pointing at it, but I don't think that's going to be accurate in the slightest. Yeah, I just need to take a break from it. But there's been some really good progress here. I mean, we've got a really short script. We've got a really efficient keyboard as far as I'm concerned. I mean, this thing is so efficient. I mean, we've got 2 text objects, 1 raycast, 1 grabbable. And the script itself is really, really light. I mean, if you look at the length of this at 16%, that's really a small script. So it's not perfect. It's definitely not done, but it's a good step in the right direction for any of those interested. And I'm going to have to pause there. Yeah, I know, Shoes. If Meta launches a virtual keyboard next week, we won. So you guys, if you're not aware of this, we had made a poll online to ask Meta to go and get us a keyboard. So let's go take a look at that. We put this on to user voice, and I guess the easiest way to get to this, let's go to uservoice.com, or it's horizonworlds.uservoice.com. And look, it's the number one thing. It's the number one most requested thing right here. So thing one I'm going to do is copy the link to user voice for you. Here we go. So if you haven't already, please do go and vote for this so we can get an easy to use keyboard. And the thing two I'm going to do is just get a direct link to this keyboard. Yeah, people like this keyboard post. I mean, it really is so necessary. And you can also hit critical when you're voting, so definitely make sure to do that. Lots of great suggestions in here as well. I mean, honestly, I just like them to get it in, and then we can add emoji and other things later. People have some really good suggestions. Like I really like Xandria's comment here to add accented letters for other languages. I think that's a really good idea. So anyway, go give that a vote. And I think that's where we're going to leave off on keyboards. So, okay. Oh, I think I might just actually call it there, guys. If you have any questions, please take this time to ask. This is definitely a good place, safe space to ask questions. Omni, it is needed for deaf. I totally agree. I mean, but that we could like go so much further on that. Like, we really need hand tracking too. Like, why is that not yet? Like, why can't you take your controllers off and just do this and have full access? There's so many things that, but there's only so much they can do. So I feel for them. Definitely feel for them. Where are we at, guys? I need to hit this button. Boom. 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 That's what I was trying to. So somehow we're 3 hours in, so I'm gonna go ahead and like call it there. But hope you've enjoyed this little keyboard tutorial, and we will catch you in the next one. I'm gonna just hang on for a little bit to answer any more questions that might pop in. So you guys feel free to ask if you'd like. And if you haven't seen the keyboard, feel free to just roll back through. looks like I'm in build mode. You can kind of see where we got to was we've got this tracking the correct row, but it's a little iffy on these positions and don't exactly know the math off the top of my head to solve it. But we talked a little bit about math earlier on. There's some really good stuff if you roll back over the last hour or so. And then we just kind of refactored a bunch to get to this state, which is crazy because this all happened in this last 3-hour segment, but it's a pretty cool starting point. And yeah. Okay, so Lakes is going to do the things that it needs to do, which is, what am I missing? I don't know that I'm missing anything. I've lost my mind, guys. Oh, I remember. I was going to change the name of this video because we didn't do anything about managing game managers because we just focused on keyboards. So we'll call this creating low capacity, or we'll call this creating efficient, optimized, low geo, low sim, creating efficient keyboard. It's gotta be surreal watching this like in the future, and you're like, I know the name of this, like, but here he is making the name of it. Oh man. All right, guys, I'm going to end this stream, but thank you all so much for coming in. Definitely go vote for that if you haven't already, and we will see you in the next one. Bye. By the way, if you're watching this in the future and want to know how you can be notified about the next one, make sure to ring the bell on YouTube so that you will get a notification when we go live. It's pretty off whenever. It's not, there's no schedule, and that's just better for my mental health. And this is just kind of a fun channel for hanging out, doing stuff. And we make a main channel, link in the bio, so feel free to check that out too. Bye for now. Oh, I have to hit the, I want to wave, but as soon as I hit this button, we're gone. Bye.